Okay guys, here is our demo for the Game of SNARKs. In principle, I will make a small screencast from the virtual machine there, which just runs the server, opens the interface. Here you can just position your ships. The valid positioning is one ship of this kind, two of this, three of this, four of this. They shouldn't be adjusting to each other, otherwise nothing happens. You get an error when you try to make the snark proof. So you can send the layout to battleship to the prover, which is the server running in the background. It just produces your proof. Right now it's a string directly serialized from libsnark, with, well, the hash is empty. So what here you can do, you can just do the same. You can click verify. Oh, sorry. You can click the verify, and if your proof is valid, it's also sent back to the server side and it's checked. So what we can do here, we can play with the numbers. You can check one of these big numbers, which are part of the proof. Basically, just make proof invalid, send it back to the server. It's verified, it's returned invalid. You can return it back, and you can just get a valid proof back. What else you can do? If your positioning is not correct, for example, two of your ships are adjacent, like this. Yeah, and I will put the rest of the ships here too. You will not be able to get a valid proof. So when you just click, you get an error. Other types of error, for example, the invalid number of ships. For example, you place this one, you don't place enough of this, or enough of this. Oh, well, just only leave blank 3 in invalid number. Or this, one more of this. So it's the same way, you click, you can get it. This is just the first step. Ideally, later we would want the snark to also govern each, each move from each user. We can check the signature, we can check the whose turn it is now, and also then move all the states updates to the plasma, because people actually tend to forget that plasma was an idea not only to reduce the transaction cost, but also to work like a map reduce. So there, some plasma operator can just accept the transactions for every user. If the snark group associated with the transaction is correct, an operator can update some global state. So it works more or less like a plasmified state channel, a quite abstract state channel because it's governed by snark. So it's just a short description of what we did, and I will upload this to the depot.